Hi, good day all. So today we are going to do May/June paper 3 year 2021. Now let's read this question. The question says the quadrilateral PQRS is shown below represents a piece of land. So this quadrilateral here, a straight plywood wall is erected from Q to S, which divides the land into two triangular portions. So we have a triangle here and we have a triangle here. Portion QRS, QRS, the bigger portion here, is a flea market, and PQS, this is the smaller one here, is a storage facility and a parking lot to serve. So this is a storage facility as well as a parking lot. The side PS is 58. PQ is 125. SR is 150. QR is 110. Angle PRS, that's by R here, is 50. Angle PSQ, that's the one by S, is 85. Show that the length of the wall QS, that is this length here, from Q, let me just get the point, from Q to S is 116. So this here is 116. They say to show that, correct to the nearest meter. Now, if we look at this, first off, we have to make sure it's not right angle triangles. These are not right angle triangles. So the rule to find either a side or angle is you're going to either use cosine rule or sine rule. Right? Now they're asking for, if we look at the two different triangles, the part that we're trying to find, we're going to use QRS. We have two sides, which is 150, 110, and a corresponding angle. So the corresponding angle for this side would be angle R, right? So basically, we have cosine rule. Now, cosine rule states it's A squared equals to B squared plus C squared minus 2AC, sorry, not AB, BC, 2BC cos A. So in this question, the capital A is your angles, and A is the one you're trying to find, the side you're trying to find. A, B, and C, the common A, B, and C are sides, right? And cos A would be your angle. So we are trying to find out QS. So QS in this case is E, right? So let's just put this. So QS is common A. B is equals to 110. C is equals to 150. And A, our angle A, is equals to 50 degrees. So let's put it in the formula. So instead of A squared, you're going to put QS squared is equal to, instead of B, you're going to put 110 squared plus 150 squared, right? Minus 2 by B, which is 110, by C, which is 150. Let's go to the side here. Cos 50 here. So we know we're going to solve this, or put this in our calculator, and you're going to get a decimal. So to avoid approximation and those type of things, you can basically just we carry across the squared sign over the equal sign. So QS would be a square root of, we know 110 squared plus 150 squared. If you put that in your calculator, you'll get 34,600 minus, right? 2 by 10 by 150 is 33,000. cos 50. So you're going to put this in your calculator, right? Square root, and let me just put open bracket 34,600 minus 33,000 cos 50 close bracket, right? And then that would give you an answer of QS being 115.7. But they said to the nearest meter, all of this is in meters. So if you approximate this, this is going to give you 116 meters. And that is how you would get this answer. That's how you would solve this question, right? That is 2 marks. Now let's look at this. A parking lot with a number of parking spaces is to be installed. Do you see these parking spaces here, right? To be installed alongside QP. All the parking spaces run exactly parallel to PS, so they are parallel, so they have the same angles. So these parking spaces have the same angles to PS than to PQ, sorry. These parking spaces have the same angle. If we were to compare angle PS with PQ, it would be the same angle from your parking space to PQ. At which angle would the side of each parking space be inclined to PQ? So they're basically asking you to find this angle right here, right? Your parking space to your wall PQ. But because they said this thing, they're exactly parallel to PS, we can say that this angle I just now drew is the same angle as this line here, PS and PQ. Now, in this case, we know this is 116, right? From above, we know this is 116 meters, right? We have a angle that is a triangle that is not 90 degrees. So again, if you're trying to find out an angle, you either use sine rule or cosine rule. Now, in this case, they give you all your sides and you have one angle, but you want to find the next angle. So if you're trying to find angles, you use sine rule. Now, if you don't know what sine rule is, their formula is in the formula sheet. This is used when all sides are given, right? And only one angle needs to be found. Right? So that all sides are given, one angle needs to be found, and one angle is given. So obviously, 85 or angle S would correspond with 125. Right? The side that is opposite the angle that we're talking about was what they will correspond with. Right? So our rule says it is A over sine capital A is equals to C over, or B, let's use B over sine capital B. Right, where A and B are your sides and A and B is your capital A and B is your angles. So again, if this is angle S, remember capital S, then side S would be this. So it would be S over sine capital S is equal to your common S with looking for P, so it will be common P over the side that is opposite that angle is 116, so it would be sine capital P, which is QS. Right, so now let's put it in the formula. We have common S, which is 125 over sine S. The sine S is 85, is equal to common P, which is 116 over sine capital P, right? And then we just make P the subject of the formula, or this P. Alright, so what we're going to do, let me just get space because I'll need space for this. We have 125 over sine 85 is equal to 116 over sine P. Alright, the first thing we're going to do is make sine P the subject. So you carry across, divide by sine P, so you're going to get multiply by sine P, open bracket, 125 over sine 85. Don't find out these values just yet. You want an exact answer. 160. Then, if we know the relationship between sine P and this is multiplication, you carry this across. So it's going to turn to divide. So sine P is equals to 116 divided by 125 over sine 85. Alright, you do this in your calc. Well, not as yet, but then after this, you want to find out what is P you're carrying across sine. If you carry across the sine, it will be sine inverse. Alright. Open bracket 116 multiply by sine 85 over 125. Right? Or even if you don't want to have a 116, because we did approximate it, you can put 115, 115.7. Let's just put it 115.7. So everywhere we saw 116, we're going to put 115.7. 115.7. 115.7. 115.7. I don't think there's any more 115s. Right? And then you put this in your calculator, sine inverse, open bracket this, and you will get P is equal to 67.23 degrees. And that would be your answer for what angle was the incline, 67.25. Right? Now they ask you, stalls are built on the land of flea market in triangle QRS. Each stall must be built at least 20.4 meters of land and 200 meters squared. Land must be used for aisles. Calculate the maximum number of stalls which can be built, showing all working. Now, if we look at the triangle that has the flea market, this is QRS. Right, they said the flea market. Right, so we're looking at QRS. Now, if it does not have a base or height, the formula that we can use, and this formula is given in your thing, area of QRS would be a half AB sine capital C, which is equals to, if we remember from before, that is, hold on, let's just use the correct thing, or the same thing throughout. A was, no, we don't need to use the whole thing throughout. Sorry. A is 110 multiplied by B, which is 150 sine C, which in this case, sine C is 50. Alright, so this is equal to, when you do this in your calculator, you get 6319.8667 meters squared. This is the total area. You need to take away these stalls because this is the total number of land needed for stalls. So area Not stalls, this is the building aisles. 2000 is building. Area for stalls would be a total area, which is 6319.8667 minus the area for built for aisles, which is 2000. When you subtract this, you're going to get 4319.8667 meters squared. And now they want to ask you the number of stalls. Now we know that 20.4 meters squared is equals to one stall. Then 1 meter squared would be 1 over 20.4, and therefore 4319.8667, right, would be 1 over 20.4 multiplied by 4319.8667 over 1, which is equal to 211.758 stalls. You cannot have 0.758 of a stall, so this is going to be 211 stalls, and that would be your answer for this part here, 211 stalls. Right? Now, if we look at part D, they said a company wishes to enclose land PQRS with chain link fence. The table below shows the advertised cost price for the chain link fence. Now, what they did give is they did give you all the lengths here. If you look in your diagram, it's PQRS, right? If we look at this, they give you PQRS. They give you everything here. So if we're talking about chaining, that would be the length around the line. So your total length would be 150 plus 110 plus 125 plus 58, which is equals to 443 meters. Right, meters, yeah. Is it in meters? Let's just make sure because I don't want to be putting the wrong unit. It is in meters. Right, now they ask you between which one. If it is 200 or less meters, you pay for 25. But if it is 200 to 50, you pay 21.50. Right, so we know if 1 meter is equal to 21.50, this is the one that we'll be using, right? The price. 1 meter is equals to 21.50, then 443. Then 443 is equals to 21.50 multiplied by 443, and this would be equals to 9524.50, and that is the cost of how much to buy the chain link fence. Okay, so number 2 says a skydiver jumps from an aeroplane at point A. So when they reach 4,000 meters away from the or above the ground, they jumped out the plane. After 10 seconds, opens his parachute. So you see at 10 seconds, that is point B, this is where he opens his parachute and falls. Right, and falls at a constant rate. The graph below shows the height that the skydiver is above the ground after t seconds. Right? How far above the ground is a diver after 25 seconds? So we are just going to look for where 25 is at. Right? 25 is here. This graph is really horrible, right? But I'll tell you guys that is right. That is actually 22.5 spaces. So this is 5, 10, 15, 20, and if we zoom in, it's not going to be really good quality, but it's one tiny space, two tiny spaces, and it is actually found between your third tiny spaces. So we know that the amount of tiny spaces we're finding for is 22.5. So we're going to use our if, then, and therefore. So if, this is for your y-axis, right? For your y-axis, if 5 spaces is equals to 500. How I got that? If you look from 0 to 500 is 5 tiny spaces, right? Then one space would be 500 divided by 5, which is 100. And we want to find out, I just now said, this point here is 22.5 spaces, right? So therefore, 22.5 or 22.5 spaces would be 100 multiplied by 22.5, which is 2,250 meters. And that is how high or how far above the ground the skydiver was after 25 seconds. The second part says, calculate the slope of line BC and explain what this value means in terms of H and T. First of all, slope, this is our next word used for gradient. So when you hear the word slope, it just means they're asking you for the gradient of BC, right? And we know gradient, or M, is equal to y2 minus y1 all over x2 minus x1, meaning we have to find two coordinates that are B and C, right? That is on the line BC. And if we look, what is the y-axis is what? Your height, and your time taken, your x-axis is time taken. Now height is this, well, we can say this would be, this is distance, right? distance, and this is time. What formula is distance over time? So they're basically asking you for, if you remember, speed is your distance over time. So when they ask you, explain what this value means, they're asking you for the speed that the speed of the fall for the who's the person that diving? The skydiver. The speed at which the skydiver is descending, basically. Right? So first off, let's find the gradient and then we'll explain what is the speed. So this we want two coordinates on B and C. So I'm going to pick something very easy. I'm picking C, which is 50 and 1,000. And then I'm going to choose B here, which is 10 and 3,000. So I am going to find the gradient using these points, 50 and 1,000 and 10 and 3,000. Right, so the coordinates is 50 and 1,000 and 10 and 3,000. So again, guys, let's reiterate. Slope means to find your gradient, okay? So we're going to take two coordinates. So we're going to call this one x1, y1, and the second one x2, y2. So we have 3,000 minus 1,000 all over 10 minus 50, which is equal to 2,000 over 40, negative 40, which is equals to minus 50 meters per second. And this makes sense because the reason why it is negative is if we look at the graph, it is actually decreasing in speed, right? Our speed is decreasing. That is why it is decelerating, basically, right? That is why it is a negative. So first off, we will say that your gradient, or minus 50 meters per second, right, is the speed at which the diver is descending. Right? The gradient also shows the rate of change. So as h, the rate of change of height, and the rate of change of time. So as height changes, the time that it takes for the height to change, basically. That's what it means. And that is it. This is 3 marks for everything. Right? Then they ask you, how long in seconds will the diver take to reach the ground falling at the same rate from B to C? Now, there are 2 ways that we can do this. If they're going to reach the ground, that means that your height is going to be 0. And your height is 0 on your x-axis. So you can either find, your height is 0 on your x-axis, meaning y is 0, right? You can find the equation of your line and then make y be equals to 0, and that would tell you where it is going to stop, right? Or you can do this because they told you it is not changing. So you can take your ruler, right? I'll put it in a different color. Connect the 2 lines, and if we see it is going to stop, or you're going to reach the ground after, let's put this in blue, come on, in blue, right? It is going to reach the ground on 70 seconds, right? So you could either just extend the graph and that would tell you where exactly it is stopping, or you're going to do this next method where you find the equation of the line. So we already know that the equation of BC is negative 50, right? We have our coordinates. So we have m is equals to negative 50. We're going to use coordinates 50 and 1,000. That's what we use for our one of the points that we use. And we're going to put it in the form y is equals to mx plus c. Right? So first off, y is 1,000 is equal to minus 50 by 50 plus c. So that's 1,000 is equals to negative 5 5s are 25, and you add 2 zeros, plus c. So c is equals to, you carry across minus 250, 2,500, that is going to turn to plus. So it's 1,000 plus 2,500. So we know that C is equal to 3,500. Right? So when this is 3,500, now you know that the equation of your line is y is equals to negative 50 x plus 3,500. And then you're going to say, we want to know when they say at which the diver reaches the ground, that means height is 0. So if your height is 0, that means y is equals to 0. So you make x the subject. You want to know the point at which it intersects the y-axis. Sorry, the x-axis, right? So you're going to say y, not y, 0. Instead of y, you're going to put 0 is equal to negative 50 x plus 3,500. We're going to make x the subject. We always want positive x, say carry across negative 50. That's going to turn to 50x is equals to 3,500. Right? So x would be 3,500 divided by 50. If we carry across divide by 50, it'll turn to multiply. Sorry, if we carry across multiply by 50, it's going to turn to divide. And when we divide this, you're going to get 70. And this is in seconds. So this is the second way. If this is 1 mark, guys, so I don't think you should do all this working. This is a lot of working just to find out at what time do they stop. So what you do is just extend the line, and you'll see that it crosses your x-axis at 70. So that means we end at 70 seconds. Alright? Then now we're going to do this one. Another diver jumps from A, airplane at A. We know that at A it was 4,000. Let me just look at the graph. Right? Yeah. It jumps at 4,000, falls at the same rate from A as the first skydiver, but opens his parachute after 20 seconds. He reaches the ground at the same time found in A3. That means he reaches the ground at 70 seconds. Draw a new constant rate, falling a new constant rate after opening his parachute. On the same axis as X on page 8, that is that axis we have, draw the graph that represents this information. So let us now look at the graph and draw that information. The first thing is, they said that the next diver starts at A. Right? So he starts at A and goes at the same rate, right, as the first diver. Yeah. Hold on, let me just add in those stuff that just now disappeared. Right? The first one was, we extended this and we saw it was at 70. Right? We put in that in blue. And the next one was the axis 25 seconds. So 25, we go up. I'll put a dotted line so you can see it. Right? And where it crosses your axis, you just go across and that will tell us the time. Now this one, again, we're going to start at A, going the same speed as from E, or the constant rate on E. So it is not going to change, right? But instead of opening at 10 like the other one did, they open at 20. Right? So when they open at 20, this is where this line is going to stop. And then after this, they are going to reach 70 seconds at a constant speed. So we are going to just draw a line connecting 70 to that first one. That is right here. And that would be your answer right here. This is how your graph would look. Let me put this in red. So this would be your answer for that question that we just now did. Right? This is the graph that we will be using for the fall of the second diver, or how the second diver fell. Right? Fell. Skydive. Right? Yeah, so that is all. They asked you for that, and that was 2 marks. Right? The next one is given that x plus y 5, 0, x minus y is equals to 9, 5, 0, 7. These are, so this means that this here is equal to 9. We're looking at the positions, and this here is equal to 7. So you're going to write it, x plus y is equals to 9, and then x minus y is equal to 7. So in the place of, so we're going to call this simultaneous equations, but I won't teach you the substitution, the elimination method, right? I'll teach you guys how to do the how to do this one, which is something we have been doing, right? So we want to replace x. So from equation 2, right, x is equal to 7 plus y. We made x the subject, so this would be equation 3. Right? And anywhere we see x, we're going to put that in your first equation, not your second equation, because we already used the second one. So it is now going to be, so we substitute x is equal to 7 plus y into equation 1. Right? That is, instead of x, you're going to put 7 plus y. So it's 7 plus y is equal to 9. So this is 7, and y plus y is 2y equals to 9. We are trying to calculate what is x and y, okay? So if we carry, we make it y the subject. Carry across 7 over the equal sign. That is 2y is equals to 9 minus 7. 7, 8, 9. So that means 2y is equals to 2. And if you're going to make y the subject, y is equals to 2 divided by 2, which is equal to 1. So we got y to be 1. And then to find out x, we have an equation here. They said that x is equal to 7 plus y. And if y is equal to 1, that means x is equals to 7 plus 1, which is equal to 8. So we know that y is equal to 1 and x is equal to 8. And that would be your answer for part B. Alright, so that is the end of May-June 2021.